All right, everybody. Let's do the Fed puzzle video. It's cold in here too, I think, because all you guys are gone. Our building's cold. All right, so we are talking about exponents. Why would we talk about exponents? You know, that it might be something you're thinking. The reason we're talking about exponents is because exponents change functions significantly. You know, what is an exponent? So we know 7 to the third power is just 7 times 7 times 7, right? And of course, that equals 349, I think. Question? But anyway, then, you know, something like x to the fourth is x times x times x times x, right? So that is the general rule of exponents, but then we have all these properties of exponents. So that's the definition, right? Properties. Okay. So no, hold on. Before we do the properties of exponents, we better go back and say that this is called the base. And this is the actual exponent itself. All right, just in case you didn't. So what we're going to do is if we have like bases, then we can combine exponential terms. Okay, so there's one rule called the product rule. And an example is x to the third times x to the second. What we do to combine is we add the exponents. Do not multiply the exponents. If the terms are multiplied, that's a product, then the exponents are added. So what is the rule for that? Add exponents. There is also the quotient rule. I bet you're guessing, is that where we subtract the exponents? Yes, it is. Okay, so that would be, let's use some different numbers. X to the fifth over x squared. And that would be x to the 5 minus 2, or x to the third. Okay, so if you see a fraction, fraction means subtraction, you know. And if you see a product, that's plus. We add them together, product plus. And then there is a third rule. There's actually, we're going to do 4. The third rule is called the power rule. And that is, you know, what if we have an exponential term and then we're raising that to an exponent? Wouldn't that be crazy? And what we do there is we multiply the exponents. Okay, so there is a time when we multiply the exponents, and that's where it is. So that is. Okay. Now here we have negative exponents. So a negative exponent, you know, based on the definition I gave you over here, you may wonder, what does that mean? If you have x to the negative third, what does that mean? Is that x to the negative x times negative x? No. That has its own definition. That is the same as 1 over x to the positive third. So a negative in an exponent tells you that we're talking about the reciprocal of something. Okay, but another way to think of it is if it's negative in one portion of the fraction, it's positive in the other portion. So some other examples. x to the negative third over x to the fourth would be 1 over x to the third, x to the fourth. And then you could add those together, x to the seventh. So there's some different things we can do to simplify, and we'll do some problems in practice. These different rules, but even though I can't write very well, there we go. Make sure you have the negative exponent definition there, the power rule, the product rule, the quotient rule, the definition of an exponent. Now let's get started. So with these, we see a fraction here, so we're going to use the quotient rule. And what does that say? That says y to the negative 7 minus negative 13. And then we know that would be y to the negative 7 plus 13, and we know that would be y to the 6th. So I'm going to say y to the 6th. Ta-da! All right. And now here we see that these are being multiplied together, so we would just add, right? And so on it goes. So go ahead and see if you can identify which rule to use, and then use those rules. And this is just using the same rules. The setup's a little different. So in this one, we want to select the equivalent expression. Now, first thing I notice here is inside parentheses, we have different bases, right? We have an 8 and a 2. So we cannot combine those like terms. But they're all being raised to the negative 4th power. And we can use the power rule to simplify the expression. So that's where we multiply, because an exponential term is being raised to a power. So we're going to multiply the exponent. So negative 4 times negative 5 is positive 20. And negative 4 times negative 2 is positive 8. And the objective here is not to do actually 8 times 8 times 8 times 8 times 8 all the way, but just to leave it like that. Because if you tried to multiply 8 20 times, you'd find it's a number too large to put in a multiple choice. So I believe that we're going to, there is actually something we could do. I wonder if they want us to do that. I think that this is, that's all they want us to do, because we could actually do some different thing, but we'll leave it like that. Okay, so properties of exponents challenge. Are you up for the challenge? I'm up for the challenge. So 7 to the negative 2nd times 7 to the 6th. What is the challenge? We just have to, we have the same bases. So what are we going to do with these exponents? Well, we're going to use the product rule. We're going to add the exponents together. And that would be 4. 7 to the 4th. I now see the challenge. 7 to the 4th is not one of the answer choices. But I do know that 7 squared would be the same as 7 to the 4th. So that's one answer. That couldn't be 7 to the 4th. Aha. If I use the quotient rule, then, oh no, I would be subtracting, and that would actually be 7 to the 8th. So that's out. But if I do the quotient rule for this one, that would be 7 squared minus the negative 2. And that is 7 to the 4th. All right, that was a challenge, wasn't it? And sometimes you have to actually just do it to see how to do it. Challenges and all that. All right. So that is the first objective, rules of exponents. Now the second objective is simplifying square roots. Okay, so I think I've uncovered good the missing piece of my instruction this year for this topic. Okay, because every year there's some students that understand it, some that are a little confused. But now just remember this part, okay? And then you will not be confused. Use any number, but let's use root 5 times root 5. What is root 5 times root 5? It's 5. Now, we could do the middle step there though. Root 5 times root 5, we can multiply them together and it would be root 25. And that is 5. But it will help you if you can go from here to here. To realizing that the square root of 5 times the square root of 5 is 5. Okay? So keep that in mind as we simplify the square root here. What we mean to simplify a square root is we want to put the smallest number possible under square root by factoring out perfect square factors. So hopefully you did some factoring last year where we think about what numbers multiply to a bigger number. And that's what we're going to do here. And let's do this. Let's change the colors. All right, so I'm going to, right here, we're going to take 180, the square root of 180, and we're going to break it down. So what two numbers multiply to 180? There's some different choices, but it ends in 0, so I'm thinking 10, 18. So I'm going to do the square root of 18 and the square root of 10. Okay, but I can break those down too. So what numbers multiply to 10? 5 and 2, right? So that's the square root of 5, square root of 2. And I also have to break down 18. That would be, how about 9 and 2. Now, if we have a perfect square, then we can take the square root. But just to say this first, the square root of 180 is the same as the square root of 9 times the square root of 2 times the square root of 5 times the square root of 2. If you multiply 9 times 2 times 5 times 2, you get 180. So we can do them separately and multiply them together and get the same answer. But what do you notice? That is 3. And also, what is root 2 times root 2? Oh, I wonder if you remember. So first of all, I saw that I had a perfect square. Secondly, I see that I have 2 root 2. Well, hopefully you remember from the beginning that 2 to the same square root is the number under the square root. So now we have 3 times 2 times root 5, and 3 times 2 is 6. Maybe I didn't find the missing piece of the instruction. I'm sure some people are still confused. But this does take some practice because it's a newer concept, right? So let's try another one. So we're going to take square root of 63 and we're going to break it up into numbers that multiply to 63. So right now I'm thinking 7 and 9. And again, there's the square root of 9. Well, I know that's 3. And then the square root of 7, that cannot be broken down. That's the final answer. 3 square root 7. Done again. All right. So if you get that far, you'll be in good shape. And then this one, that usually confuses some people. But remember, we can use the same idea, and also things under the square root, separate square roots, can be multiplied together. So what I'm going to do is multiply everything together under one big square root. Well, I'm not actually going to multiply the numbers together because then I'm going to end up breaking them down. But let's write it under one big square root. So 3 times 5 times 10 times x to the 4th times x squared. All right. So using those rules of exponents, can we combine that? We can, right? That would be x to the 6th. And then why don't we just think of this separately? So then this first part is the assignment we just did, and the second part is the assignments from the exponents. So we have x to the 6th. Okay, we'll leave that for a second. And let's talk about the 3 times 5 times 10. We can, the square root of 3 times 5 times 10. The square root of 10 is the square root of 2 times the square root of 5. But now I have this written as root 3, root 2, root 5, root 5. See, because I got this root 5 and this root 5. And the square root of 10 is broken down into 2 and 5. And so what do we say about this? That's just 5. And then what about these? They're both under the square root. So we could multiply them together. 3 times 2 is 6. So the first part of this answer is 5 on the outside, square root of 6 on the inside. And then x to the 6th is, where does that go? Well, x to the 6th, if we're trying to break that down into perfect squares, that would be x squared times x to the 4th. I mean, do I have to do that? How many squares? That would be the square root of x to the 6th is the same as 3x squared, right? Because using the product rule, we add exponents when we multiply terms. So multiplying these 3, you would add their exponents. 2 plus 2 plus 2 is 6. All right. Now let's take the square roots. Square root of x squared is x. And then 3 x's makes x to the 3rd. And it's on the outside of parentheses, so it's going to be 5x to the 3rd root 6. This one will definitely take some practice for you because we're putting material you have to master in some assignments into this one. So by the end of the week, you still have questions on this one, it's okay. Just make sure you have your red problems listed so that we can go over them together. All right, get started, and then we'll pick this up in class on Zoom. See you there.